Here we're going to go through a second example of one variable statistics. Here we have a class of physics students, and they are asked to determine the value of a certain hanging mass using the method of torques, whatever that is. We're not interested in that here. Each group determined an experimental value for the mass in grams, as shown right there. And we want to report the class's best estimate for the value of m. So what we're going to do here is we're going to go into our graphing calculator, and we're going to, well, first of all, we're going to say that n equals 6. So that's easy. Now we need to find the mean. Now you could do that pretty easily by just adding these numbers up and dividing by 6, but we need some other things from the calculator, so we might as well just use the calculator to do a good portion of this work for us. So what we want to do is we want to do some statistics. So I need to hit this stat button right there, and we are going to edit, which means we're going to put in our data points. So I'm going to hit enter. Now, to save time on this video, I've already entered those 6 data points in there. Once we've done that, we need to quit this by hitting the second function and then the quit button, which is above the mode. Now we need to go back into the stat menu, and we're going to now calculate. So we need to toggle over to the middle one, and we're at one variable statistics. So I'm going to hit enter a couple more times. And what this tells us is that the mean, let's scoot this over a bit, the mean is 38.16. The other value that we need from this screen is the S sub x value right there. So let's write that down. S sub x is 0.39833. That's all we need from that screen. So what we're going to do from the S sub x is we're going to then, from it, calculate the standard error. Sx is not the standard error. What we want is the standard error, which is found by taking Sx divided by the square root of the number of data points. We're going to go 0.39833 divided by the square root of 6. You can see why it's going to be nice to have a calculator handy here. And when you do that, you need to round that answer to one significant figure. No matter what it is, round it to one significant figure, which in this case is 0.2. We report our answer then as the mean rounded to this decimal place from the standard error, plus or minus the standard error, like this. 38 point, we need to round to the tenths place. So this 0.166666 needs to be rounded to 0.2, plus or minus the standard error. Let me put that in parentheses. And then what's the unit? If we go back to our problem, it's grams. As best this class could figure out, we believe that the mass of that unknown is 38.2 plus or minus 0.2 grams.